All right, this is the last section from chapter 774 on proportionality and parallel lines. The first slide here are the two theorems that go with the section. The theorem 7.5 at the top goes with the first three examples, and the bottom theorem goes with the last example. These are both part of your notebook check. And again, once this is in your notebook, you'll be done with your notebook for the quarter, and you can hand it in at any time. Monday, I'm going to put up the notebook checklist just so you know what needs to be in your notebook. So the theorem 7.5 says that if a line is parallel to one side of the triangle, so over there BE and CD are parallel, and intersects two other sides, then it divides the segments into proportional lengths. So if you have two parallel lines, you can make a proportion by finding the point that is not part of the parallel sides. So A is not part of the parallel sides. And then you just go down the side and read the first segment, AB, and over the second part of that segment, BC, which is the top part of the triangle, equals, and then you read down the other side starting at point A again, A to E, and then over E to D. And then that's your proportion, and that's how you can set up most of these problems. Converse just says that if you go backward, if you actually know all the numbers and you make a proportion, you can say those definitely are parallel. So in this case, if you look at your two possibly parallel sides there, AC and ED, you notice that B is not part of a parallel side. That means that point B is where you start when you read this. That is not what they have over there, is kind of upside down of how you should do it. So I would say that it should be BE. You start at point B and go down one side, BE over EA equals BD over DC. Start back at B and go down. It's just flipped upside down, so it's technically still correct, but I would start at point B instead of point A when I did my proportion. Now on to the first example here. This is a pretty simple example. It says if AB is 6, BC is 4, AE is 9, find ED. So first we're going to find the point that is not part of the parallel segment. In this case, it's point A, because one of the parallel segments is BE and one is CD, so the only point that's not part of a parallel segment is A. Then we set up the proportion, start at point A, then read down one side, so A to B and B to C, so AB over BC, and then go back to point A and do it again, AE over ED, and then after that you just plug in the numbers from the problem, cross multiply and divide. So AB is 6, BC is 4, so it's 6 over 4 on the left side. And on the right side, AE is 9, and we're finding ED, so I'm going to make that x. Cross multiply the top left times the bottom right, which is 6x, and the bottom left times the top right. 9 times 4 is 36, and then divide to get x equals 6. And so that means ED is also 6. All right, that's pretty simple. Sometimes, though, you will find out that you do not have all the information you need, and usually all you have to do is subtract, and you'll see that in the next example here. So here we have number 4 from the back of the 7.4 worksheet. So if you want to put this down, you can put this in your notebook, or you can just write on your paper. It's like a free problem for later. So we just have this triangle. It's unlabeled, so you have to find the point that you would start at from the large triangle. So there's the top point, the point on the bottom left, and the point on the bottom right. You could see that the point that is not part of a parallel side is at the top, so we're going to start there when we make our proportion. If you notice, they gave us the top left and the bottom left, and then they gave us the top right and then the whole right side. We don't want the whole right side, which is 33 units long. We need the bottom right part of this triangle, because you don't compare the long side. So you have to subtract the long side minus the part we already know to get the other short side at the bottom right. 33 minus 11 is 22. Again, we can't use 33 in our proportion because it's not part of the side, it's the actual whole side. So usually you're just going to have to subtract to get that other part. After that, you just substitute the numbers in and solve for x, so that if we put this in a proportion, you start at the top, go down one side, so it's x divided by x plus 12. And then we're starting at the top and going down the right side, 11 divided by 22, not 33, because 33 is not the bottom right part of the triangle. 22 is, so 11 over 22. Again, you're going to cross multiply. 22 times x is 22x. And then when you have two terms and you cross multiply, you actually have to put the two terms in parentheses. So the x plus 12 has to go in the parentheses with the 11 on the outside. If you don't do this, you're going to get the wrong answer every time. So make sure you're putting it in parentheses. Distribute, 11 distributes in to give you 11x, and then 11 times 12 is 132. You have to remember to distribute. Again, if you don't distribute, you're going to be wrong every single time. So we need to get the x's to the left side because the numbers are already by themselves on the right side, so we're going to subtract 11x from the right side to the left side. 22x minus 11x is 11x. And then to get the answer, that's 11 times x, so the opposite of times is divide to get x by itself. And 132 divided by 11 is 12, so x is 12. You did this last year in Algebra 1, and you probably did this either if you took 9th grade math with Miss Spring or Miss Woodson, you did it in there, or you did it in 8th grade math, so this should be, you've done it at least 2 different times, should be old hat for you. All right? There's one more problem we're going to do like this that is a little bit harder, but not too much harder. Okay. So this is just another example from the book. It says if CE is t minus 2 and EB is t plus 1, and CD is 2 and CA is 10, find T and segment CE. So you need to have 2 answers to solve this. So first, find the point that's not part of a parallel segment. In this case, it's point C, because the 2 parallel segments are AB and DE, so you cannot use any of those points. You have to use point C. Then read down the left side of the triangle starting at point C. So it's going to be CD over DA equals, and then you go back to C and read down the other side. CE over EB. And then we substitute in each value. Well, they don't give us DA, right? They give us CA, and CA is the full side. So again, you know what CD is, you know what CA is, you subtract the 2 numbers to get AD. CA is 10, which is the full side. CD is 2. You would need what's left over. 10 minus 2 is 8. So when I set up my proportion, I'm going to put 8 in for DA. So CD is 2, DA is 8, so 2 over 8 equals CE is t minus 2, and EB is t plus 1. Cross multiply this time, so I'm going to get 2 times parentheses t plus 1 equals 8 times parentheses t minus 2. So again, we're cross multiplying. Distribute those numbers into the parentheses. If you don't distribute, it's always wrong. 2 times t is 2t, and 2 times positive 1 is 2. Then on the other side, the equal sign, 8 times t is 8t, and 8 times negative 2 is negative 16. So we have 2t plus 2 equals 8t minus 16. Now we got to solve for t. I'm going to move the positive 2t from the left side of the equation to the right side of the equation by subtracting it. I'll be left with just a 2 on the left side. 8t minus 2t is 6t. And then break down the 16. Now I need to move the numbers over to the left side. The opposite of a minus 16 is a plus 16. Whatever I would do to the right side, I have to do to the left side. So negative 16 plus 16 cancels. On the left side, 2 plus 16 is 18. So I'll get 18 equals 6t. Now I can divide by 6 to get the t by itself. 18 divided by 6 is 3. And then 6 divided by 6 will leave you just with t. So t is 3, but the problem isn't over because it asked what CE is also. According to the original problem, CE is t minus 2. So we just plug 3 in for t, and 3 minus 2 is 1. And then finally, using the other theorem, we have to determine if the lines are parallel. So this one says determine whether JK is parallel to NM. Justify your answer. So we look at what the 2 possible parallel lines are, JK and NM, and we find the other point, which would be L. So we're going to set up the proportion starting at point L and reading down the side. So we've got LM divided by KM, because we're going down the top part of the triangle, starting at L because it's not part of a parallel side, and then going across the bottom, LN over NJ. This is another one of those problems where you have to subtract to get your numbers, because we need the number for, they give us JN and JL. JL is the full side. JN is the second part of the line. So we have to subtract 30 minus 18 to get ln is 12. So now we're going to substitute the numbers in. I plugged in 35 for LM according to the problem and 21 for KM according to the problem. And then LN, again, we had to subtract 30 minus 18 to get 12 for that, to get the partial side because they gave us the whole side instead. And then NJ is 18. So we've got 35 over 21 equals 12 over 18. When you cross multiply these, if the cross products are equal, then the lines are parallel, and if they're not equal, they're not parallel. So I'm just going to cross multiply and see what that gives me. 35 times 18 is 630. 21 times 12 is 252. The cross products are not equal, so the segments are not parallel. And if we multiplied and they were equal, then they would be parallel, but they're not in this case. So that's pretty much all there is to this section. It's just knowing how to set up the sides. They're set up the same way every single time. Sometimes you have to subtract to get one of your pieces, and sometimes you don't. So you just have to start learning to recognize that.